Hello and welcome. In this video I'm going to discuss about transverse statical stability. So first we will discuss about what is the difference between lest and heel. So lest is due to cargo shift, ballast, or you can say it is due to internal forces, whereas heel is due to wind, waves and external forces, that is external forces. There is transverse inclination due to internal forces is known as list, and transverse inclination due to external forces known as heel. And in list there is a change of the position of the center of gravity. Position of center of gravity changes in case of list, and there is no change on the position of center of gravity in case of heel. Now we will discuss about transverse metacentre. Before that, let's try to understand this picture. So in this picture you can see there is the point B, it is known as center of buoyancy, point of center of buoyancy, and Z is known as center of gravity. From this point there is a force of buoyancy which acts in upward direction, and from this point Z there is a force of gravity which acts in downward direction. Both the forces are equal and in opposite direction. So these are equal and opposite direction, therefore this vessel is floating. So I think you all have understood. Then we will discuss about transverse metacentre. So when vessel is heeled, it is not listed. When the vessel is heeled, the force in this, as you can see in this picture here, the vessel is heeled. The force of buoyancy acts from a new position of center of buoyancy. So the center of buoyancy, that is B, is shifted from B to B1. There is new center of buoyancy, that is B1, and the force of buoyancy acting upwards. And this line of force of buoyancy cuts the center line at a position M, and this position M is known as transverse metacentre. So how to define transverse metacentre? So the force of buoyancy acts from a new position of center of buoyancy when a vessel is heeled. The force of buoyancy line cuts the center line of the ship at a point, and this point is known as transverse metacentre. And distance of this point from keel is known as Km. Now let's discuss about metacentric height. So metacentric height is the vertical distance between the center of gravity and the metacentre. So vertical distance between center of gravity, that is G, and metacentre, that is M, is known as GM, that is metacentric height. This line is known as metacentric height. This line is known as GM, is known as metacentric height. Now let's discuss about righting lever, that is denoted by GZ. So when the vessel is heeled, we all know that the force of buoyancy acts from a new position of center of buoyancy. The force of buoyancy will act from a new position. This is B and this is B1, and this is the new position of center of buoyancy. So it will act from this point. Force of buoyancy acts from a new position of center of buoyancy, and this line is separated from center of gravity. This line is separated from the center line, or you can say the force of buoyancy line is separated from center of gravity G by a horizontal distance, and this distance is known as GZ, and this distance is known as righting lever. For small angle of heel, let's say up to 15 degrees, GZ is equals to GM sin theta. For large angles, GZ equals to sin theta bracket GM plus half tan square theta. Now let's discuss about righting moment. So as we all know, when the vessel is heeled, the force of gravity and buoyancy being equal and opposite become separated by a horizontal distance, as discussed earlier, and this horizontal distance is known as what? Righting lever. And this will form a couple which tends to return the vessel upright. So this righting lever, that is GZ, this forms a couple, and this will tends to return the vessel upright. And this tendency is known as righting moment or moment of statical stability. Righting lever or righting moment or moment of statical stability, and it is given by formula righting moment is equals to W into GZ. W is displacement into righting lever. So this much is important from this topic.